Here we are going to do the elimination method, and we kind of talked about and proved to ourselves why this method works. And when we add the equations together that have a common solution, we will get yet another equation that will also have the same solution. And like I said, we've shown this in class, so we know that it works. But let's use this method to solve some systems of equations. This particular system of equation lends itself really well to elimination because it's already set up. You have an x plus an x and a 3x, you have a 4y and a negative 4y, and you have a 1 and a 6. When you add these together, watch what happens. You have x plus 3x is 4x. 4y plus a negative 4y is nothing. And 1 plus 6 is 7. So you end up with this really cool equation that you got rid of the y's in. So let's divide both sides by 4. Divide both sides by 4. And you'll get x is 7/4, which if I reduce that, you'll get 1 and 3/4. And it is okay to write this as a decimal or leave it as a fraction. You could even leave it as an improper fraction for now. So it'll be 1.75. Now, I know what x equals, but I want to know what y equals. So just like in substitution, I'm going to go back up to one of the original equations, plug in my x, and solve it. I'm going to pick the first equation because it has a singular x. There's no multiplication. So I have 1.75 plus 4y is equal to 1. And if I subtract 1.75 on both sides, I will end up with 4y equals negative 0.75. And then we go ahead and divide by 4 on both sides. Thanks. Y is equal to, and then I'm going to rewrite this as, change it back to a fraction because this will be nice and easy, negative 3/4, and then divide it by 4. And if I use keep change, negative 3/4, or keep change flip, I'm sorry, and you will get negative 3 over 16, negative 3/16. You can decide whether or not to leave it as a decimal or fraction, but in this case it worked better as a fraction. So these are going to cross at the point 1 and 3/4 and negative 3/16. So not always do they cross in a nice even place, and that is why algebraic solutions are beneficial. You can graph and you can guess, or you may even be able to graph on the calculator and make a solid guess, but you have to be able to find definitively what the solution is. Let's try another one that doesn't have as bad of an answer. Let's try this one. Negative 3x minus 5y equals negative 21, and negative 9x plus 2y equals negative 63. Now this one doesn't have a positive and a negative that nicely eliminates. So what we have to do is we have to make it have a positive and negative that nicely eliminates. And if I look at the x's, 3 and 9, there's a factor there. 5 and 2, there isn't. There's nothing I can multiply by 2 to give me 5. And there's not really any nice whole numbers I can multiply by 5 to give me 2. It doesn't always have to be a whole number, but we want to stick with easier. Easier is always better. So let's make this, I want to make it a positive 9x, so that positive 9x minus 9x will cancel out. So let's multiply this by negative 3. And I'm going to create a new equation by scaling the old equation, because we know that when we scale it, they're really equivalent. They graph the same line. So negative 3 times negative 3x is positive 9x. Negative 3 times negative 5y is positive 15y. And negative 3 times negative 21 would be a positive again, and that's going to be 63. Look what happens. When we add the new equations we just got together, the x's will cross out, because negative 9x plus 9x is 0. And then you're going to have 15y plus 2 more y, we get 17y. And 63, or negative 63 plus 63 is just 0. And if I divide by 17, y is equal to 0. Now I can go back up and I can plug into any equation I want. I'm going to plug into the second one here. Negative 9x plus 2y equal to negative 63. Y is 0, so I'm going to go ahead and plug that in. And I'm going to get negative 9x plus 0, so just negative 9x equals negative 63. And then when I divide by negative 9 on both sides, x is equal to positive 7. So my solution is 7, 0. That is where they cross.